The orbit of 3I Atlas is the first thing that drew astronomers' attention. The fact is simple and uncontested. Its trajectory is hyperbolic, meaning it is not gravitationally bound to the sun. Objects like this do not originate in our solar system. They pass through once, then disappear into interstellar darkness forever. But the deeper researchers looked, the more details of this orbit began to defy expectations. The first puzzling clue lies in the inclination. 3I Atlas entered the solar system from a direction not associated with any known stellar stream. Most interstellar objects trace paths that can be linked to broader galactic motions, but Atlas approached from an angle that does not align with these flows. The scientific interpretation is that Atlas may have been ejected chaotically from a planetary system long ago, perhaps during the formation of giant planets. Yet some analysts quietly note that its exact entry vector appears oddly precise, almost as if calculated rather than random. There is another fact. Atlas accelerated slightly as it passed near the Sun. Not dramatically, but enough for sensitive instruments to detect. Officially, this was attributed to outgassing, jets of vapor from melting ice pushing the object forward. But the spectrum analysis did not show the expected chemical signatures. There was no clear evidence of water vapor or carbon monoxide, the usual culprits behind cometary thrust. This absence caused several researchers to question whether the acceleration could really be natural. In private discussions, a few even wondered if the force resembled controlled correction rather than chaotic sublimation. Then there is the curious detail of the outbound trajectory. As Atlas departed the inner solar system, it shifted a few arc-seconds off the predicted path. Minor deviations are normal, yet this particular shift happened during a window when several observatories simultaneously reported technical issues. According to official logs, these were routine glitches in data transmission. Still, one technician claimed that the tracking signal blinked out for nearly 30 seconds, and when it returned, the orbit calculation had changed. Why the data gap occurred at the exact moment of the unexplained deviation is something no spokesperson has fully addressed. Another oddity involves the object's radiant point, the location in the sky from which it appears to have come. Multiple astronomers noted that the radiant fell within a region associated with an unusual cluster of faint infrared sources. Most likely, these are just cold dust clouds. But some theorists pointed out that the distribution looked deliberately structured, with equal spacing between several of the sources. Whether this means anything is unclear. But the timing of Atlas passing through that region has sparked quiet speculation that it might not be coincidence. A few anonymous contributors on scientific forums hinted that certain early trajectory data points were removed from public databases and replaced with smooth values. When asked why, database administrators responded that the initial points were mathematically unstable. Yet the absence of the original numbers makes independent verification impossible. Taken individually, each anomaly can be explained. Together, they paint a more complex picture, one that suggests 3I Atlas may not just be a wanderer, but a messenger from a region of the galaxy we have yet to understand. Whether the orbit reveals a natural origin, a pattern, or something more intentional is uncertain. What is clear is that the path Atlas followed is unlike anything seen before, and perhaps that in itself is the most unsettling part. Tracing the origin of 3I Atlas should have been a straightforward task. In theory, every interstellar object carries a kind of cosmic fingerprint. Its incoming trajectory, when calculated backward, points toward the region of space it once called home. Scientists attempted exactly that with Atlas, plotting its path and extending it through thousands of years of stellar motion. However, the line that should have intersected a clear stellar neighborhood instead led into an oddly empty region of the sky. This absence itself is a fact. The backward orbital integration suggested no immediate parent star within the expected margin of error. The interpretation was initially mundane. Perhaps Atlas had been traveling for millions of years, long enough for its birthplace to drift far from the calculated path. But soon, other patterns emerged. Some astronomers, comparing Atlas's trajectory with star catalogs, noticed that its reconstructed path passed near a region associated with a set of faint, nearly invisible objects detected only in deep infrared surveys. They were too dim to classify confidently, too cold, too quiet. Some described them as unusually isolated. A few researchers pointed out that if these objects were rogue planets or remnants of a collapsed stellar system, they could theoretically launch debris like Atlas into interstellar space. Yet even among those scientists, there was hesitation. The infrared anomalies were spaced in a surprisingly geometric pattern, evenly distributed as if placed on a grid. This was likely a coincidence, yet the symmetry was hard to ignore. In the background of the scientific debate, other rumors began circulating. Several amateur astronomers reported that early position data for Atlas, available briefly on public servers, disappeared within days. When questioned, observatories claimed the numbers were preliminary and removed to avoid misinterpretation. Still, some users insisted that the deleted coordinates pointed more precisely toward the region of the strange infrared sources, and that the revised data softened the alignment. Whether this was accidental or intentional remains unknown. One particularly intriguing element surfaced months later. Satellite instruments designed to monitor cosmic rays detected a subtle burst of high-energy particles arriving from nearly the same direction Atlas was traced to. The burst was real, recorded in multiple independent arrays. The interpretation was unclear. It could have been caused by a distant supernova, a flaring brown dwarf, or even a collision between icy bodies. Yet some analysts noted that the timing of the burst appeared suspiciously close to the period when Atlas entered the inner solar system. Nothing conclusively links the two events, but the parallel raises questions. An anonymous employee at one observatory claimed that a restricted internal memo suggested non-natural periodicity in the particle burst. The memo has never surfaced, and the observatory denies it exists. Nonetheless, the story continues to circulate, fueling speculation that Atlas may have come from a system undergoing some form of energetic activity. More curious still is the fact that attempts to run more precise backward simulations of Atlas's orbit were halted when several servers used for orbital modeling suffered unexpected crashes. Officially, the failures were attributed to an overloaded network during peak observation periods. Yet internal logs, quietly shared online, showed multiple attempts to access restricted directories just minutes before the system failures. Whether this was simple error, human interference, or something else entirely is unknown. The truth is difficult to pin down. Atlas may come from a long-dead star system. It might have been ejected by gravitational chaos. Or, as a few theorists whisper, it could originate from a region intentionally shrouded in obscurity. Whether that obscurity is natural or engineered is something no official source has addressed. And perhaps that silence is the strangest clue of all. The path of 3I Atlas through the solar system is not just hyperbolic. It carries subtle irregularities that have puzzled astronomers since its discovery. The fact is clear. Atlas's velocity and angle of approach differ from most known interstellar objects. Oumuamua, for example, followed a shallow, nearly planar trajectory, while Atlas enters at a steeper, more unusual inclination. The immediate interpretation was that this might be a random consequence of gravitational ejection from its parent system. Yet even this simple explanation leaves questions. One anomaly lies in the way Atlas's orbit reacts to the Sun's gravity. Data shows slight deviations from the predicted Keplerian path, far beyond measurement error. Officially, these are attributed to non-gravitational forces, like outgassing. But spectral analysis found minimal evidence for volatile release. A few researchers privately noted that the acceleration seems directionally consistent rather than stochastic, as if a subtle correction is occurring along its vector of motion. Some in the community whisper that the force is too clean to be natural, though no one can verify it publicly. Another curious point is Atlas's perihelion. As it approached closest to the Sun, its trajectory appeared to shift by mere arcseconds, tiny, almost imperceptible, yet consistent across multiple observatories. Standard models predict slight scattering from solar radiation pressure, but the magnitude of this shift exceeds expectations. A few anonymous astronomers speculated internally that this could resemble the effect of a low thrust applied consistently along one axis. The idea is rarely mentioned outside private conversations, yet it lingers in forums and leaked notes. Adding to the intrigue is the absence of orbital debris or natural fragments accompanying Atlas. Typically, objects ejected from stellar systems carry smaller pieces, dust, ice, or shattered fragments. Yet telescopes observed nothing nearby, a fact confirmed by independent surveys. Some analysts suggest that Atlas may have been cleaned by unknown forces, or perhaps it has traveled long enough that any companion debris dispersed beyond detection. Others hint, quietly, that such emptiness is unusual for an object of its size and composition. A further oddity involves the timing of observational data. In multiple instances, precise tracking measurements from certain radar arrays were delayed or temporarily inaccessible. Official statements attribute this to routine maintenance. However, one former technician, speaking under condition of anonymity, confirmed that access to raw orbital logs was restricted almost immediately after unusual positional readings appeared. Why these specific windows were blocked, and why the logs returned altered or smoothed, is not explained. Finally, the radiant point from which Atlas appears to originate seems almost deliberately obscure. Backward extrapolation of its trajectory does not intersect any well-known nearby stellar system with high confidence. Instead, it points to a sparsely mapped region, where faint infrared sources are poorly cataloged. Some researchers suggest this is merely a coincidence of limited data, while others quietly propose that the object may have been ejected from a hidden or now extinct system. The mystery deepens because the region contains subtle gravitational anomalies detectable only in long-term surveys, anomalies that some astronomers have flagged but not publicly analyzed. Taken together, these orbital irregularities suggest that Atlas's path may carry more information than is immediately apparent. Whether this reflects natural chaos, unseen forces, or something more deliberate remains unknown. The subtle shifts, the clean path, and the obscured origin leave room for speculation. Some believe the orbit itself may be a message or a clue, but no one can say for certain. Perhaps the answers lie beyond our current instruments, waiting for someone patient enough to follow the trail. Atlas's orbit, while hyperbolic, carries subtle irregularities that have caught the attention of orbital dynamicists worldwide. The fact is that its speed at infinity, the velocity it carries after leaving the Sun's gravitational influence, is higher than expected for an object ejected by typical planetary scattering. Standard models suggest that ejected comets or asteroids would display velocities within a predictable range. Atlas, however, exceeds that range by a small but measurable margin. The immediate interpretation is that it could have been accelerated by an unusually massive planet or binary system in its home star system. Yet some researchers quietly note that such precise acceleration is uncommon, even in chaotic planetary ejections. Another observed anomaly involves the object's orbital plane. Atlas does not lie neatly within the galactic disk, as many interstellar objects do. Its trajectory tilts at an angle that places it in a relatively underpopulated region of nearby stellar space. The standard explanation is simple. Random ejection vectors produce a wide spread of inclinations. However, the consistent direction of its tilt, combined with the lack of known nearby stellar sources along that vector, has led a few orbital specialists to speculate privately that the trajectory may not be purely random. Some in the community suggest the object may have been shepherded or influenced by forces not yet accounted for in conventional models. A curious feature noted by multiple observatories is a small but measurable drift in Atlas's outbound path after perihelion. The object appears to deviate fractionally from the predicted trajectory, in a way that is inconsistent with solar radiation pressure alone. Spectroscopic surveys failed to detect sufficient volatile material that would explain non-gravitational thrust. Several astronomers, speaking anonymously, have suggested that the deviation could indicate an internal mechanism of propulsion, though this remains purely speculative. Others argue that it might be caused by an unusual shape or internal density distribution, but no conclusive model has been published. Data gaps have only fueled speculation. Some tracking radars briefly lost contact with Atlas for seconds at a time during its closest approach. Official reports describe these lapses as routine equipment resets. Yet insiders hint that raw logs from these periods contained unusual positional readings, which were later smoothed or removed from public databases. Why the readings were altered is unexplained. One researcher commented that the real data may have shown a pattern that someone didn't want widely known, though this claim cannot be verified. The orbital reconstruction also points toward a sparsely mapped portion of space several light years away. Few stars are cataloged with precision in that region, yet faint infrared sources exist, suggesting either unseen stellar remnants or distant brown dwarfs. Some orbital modelers have privately speculated that Atlas may have originated from one of these faint systems. Others wonder if the sources themselves were merely placeholders in incomplete surveys, leaving room for speculation about hidden stellar neighbors or undiscovered gravitational anomalies. Taken together, these deviations, velocity above expectations, unusual inclination, unexplained drift, and gaps in observational data, form a puzzle that remains unresolved. They hint at a history that may be far more complex than a simple ejection from a random star system. Whether these clues reveal natural chaos, subtle gravitational influences, or something entirely unexpected is unknown. Some suggest the orbit itself is trying to tell us something about its origin, but whether it is a message, a coincidence, or evidence of unknown astrophysical processes remains an open question. The search for 3I Atlas's home system is more complex than it first appears. The fact is that backward orbital projections, even accounting for thousands of years of galactic motion, do not lead to any well-cataloged star within a reasonable distance. The standard interpretation is that Atlas has been traveling through interstellar space for millions of years, long enough that its parent system has moved far from the original trajectory. Yet the lack of a plausible origin leaves a gap in the narrative, and in science, gaps often invite speculation. Some astronomers have noted that the reconstructed path passes near a sparsely mapped portion of the sky where faint infrared objects are detected. These objects are too dim to be characterized fully, yet they could represent cold stars, brown dwarfs, or planetary remnants. The interpretation offered publicly is cautious. The infrared sources are likely background noise or distant celestial bodies. Privately, however, a few orbital analysts suggest that the alignment is striking, as if Atlas's path intersects a region unusually rich in potential ejection sources. Whether this is meaningful or coincidental remains unconfirmed. Another anomaly involves the hyperbolic excess velocity, the speed at which Atlas leaves the Sun's gravitational influence. It exceeds expectations for most natural ejection scenarios. A few researchers speculate in private that such a speed could result from an unusually strong gravitational assist, perhaps from a binary star system or a dense cluster. Even stranger, when simulating potential ejection paths, the trajectory occasionally passes close to faint, poorly characterized objects whose presence is barely detectable in survey data. The probability of random alignment with these sources seems low, yet the data are insufficient to draw firm conclusions. Data handling has also raised eyebrows. Some early measurements of Atlas's incoming vector were temporarily removed from public archives. Officially, these corrections were necessary to account for calibration errors. Yet astronomers familiar with the raw files noted subtle changes in the reported path, smoothing irregularities that might have revealed more precise information about the origin region. Whether this was a standard procedure or a precaution against sharing sensitive positional data is unknown. No public explanation accounts for the exact timing or selective removal of those points. A few researchers have additionally pointed out an apparent coincidence involving galactic stellar streams. Atlas's entry path crosses near the projected positions of several stars moving in roughly the same direction, yet none match the precise vector needed to account for its speed. Some believe this could indicate that the object has traversed a hidden or uncharted gravitational corridor, potentially influenced by a massive but unseen object. Others caution that the effect could be an artifact of incomplete catalogs, emphasizing the uncertainty. Finally, subtle hints from radar and optical tracking add to the intrigue. Several datasets recorded brief, unexplained fluctuations in velocity or slight deviations from predicted paths. Official reports attribute these to measurement noise or data smoothing. Still, some astronomers privately suggest the anomalies might hint at an unseen influence, gravitational or otherwise, acting on Atlas as it passed through the solar system. The exact source of this influence, if real, is unknown. Taken together, the trajectory and its anomalies leave room for speculation. Atlas may be a natural wanderer, a relic of a chaotic ejection from a distant star system, or something more enigmatic. The missing origin, the unexplained deviations, and the obscure infrared sources all create a puzzle that has yet to be solved. Whether it will eventually lead to a conventional explanation or something far more surprising is a question the astronomical community continues to wrestle with, leaving the trail of Atlas as mysterious as the depths of interstellar space itself. The trajectory of 3I Atlas has not remained perfectly predictable. The fact is that as it passed through the inner solar system, careful measurements revealed slight deviations from the expected hyperbolic path. These deviations are very small, arcseconds at most, but they were observed consistently across multiple telescopes. The official explanation attributes them to minor solar radiation effects or measurement uncertainties. Yet the precision and directionality of these shifts raise questions that are not fully addressed in the literature. One particularly intriguing detail involves non-gravitational acceleration. The object's velocity increased marginally as it approached perihelion, an effect usually caused by outgassing in comets. Yet spectral analysis found little to no evidence of water vapor or other volatiles that would explain thrust in the observed direction. Internally, Several astronomers have speculated that the acceleration may have been caused by a more controlled mechanism, though no evidence exists to support such a claim publicly. Some even quietly suggest that if Atlas were engineered, this subtle motion could be intentional, yet this remains purely conjectural. Another curious factor is the apparent resilience of Atlas's path to gravitational perturbations. In simulations, the object passes near regions where minor bodies or small planetary remnants could slightly alter trajectories. Most natural objects experience measurable deflections in such conditions, yet Atlas remained unusually stable. A few researchers have noted privately that the lack of expected deviations could indicate a more uniform mass distribution, or perhaps an unknown effect acting on the object as it moved. No official commentary addresses this apparent anomaly. Timing anomalies in observation logs add to the mystery. Some radar stations briefly lost Atlas from tracking during the closest approach. Official statements claim equipment resets or atmospheric interference, but insiders hint that the raw logs may have shown unexpected positional behavior. When these logs were later released, data smoothing had been applied, removing the original irregularities. Why the original records were altered, and only for the critical approach window, is unexplained. Atlas's inbound trajectory also intersects a region of space populated by faint infrared sources, cataloged only in partial surveys. The fact that the object passed through this sparsely mapped area without leaving detectable debris is unusual. Some theorists have suggested that it might have originated from a small, hidden star system within this region, possibly even one whose components have since dissipated or remain undetected. Others note the region's gravitational fields may be more complex than understood, subtly guiding the object's path. Adding to the uncertainty, slight polarimetric anomalies were recorded during Atlas's closest approach. The object briefly reflected light in a manner inconsistent with a randomly shaped natural body. While officially attributed to measurement noise or data processing artifacts, several astronomers have noted privately that the alignment of these reflections across multiple observatories is statistically unlikely to be coincidental. Taken together, these subtle orbital influences suggest that Atlas's path may contain clues about its origin, composition, or even unknown forces acting upon it. Whether these anomalies are natural engineered or simply artifacts of limited observation remains unresolved. What is certain is that Atlas's orbit refuses to be fully explained, leaving astronomers with a trail of data points, gaps, and hints that continue to provoke curiosity. The true story behind these slight deviations may remain hidden, just out of reach, leaving more questions than answers in its wake. The orbit of 3I Atlas is more than a simple hyperbolic path. It is a record of its journey through interstellar space, and it holds subtle clues about its origin and the forces it has encountered. The fact is that precise astrometric measurements show small, consistent deviations from predicted positions, both inbound and outbound. These deviations are small enough to be dismissed by casual observation, but persistent enough to attract attention from orbital dynamicists. The initial interpretation suggests natural irregularities, slight gravitational influences from unseen minor bodies or interstellar gas clouds. Yet some researchers quietly note that the pattern of these deviations is too systematic to be fully random. One anomaly involves the object's angle of approach. Atlas entered the solar system from a direction not associated with any known stellar stream. Most interstellar objects trace paths that roughly align with the local motion of nearby stars. Atlas, however, approaches from a sparsely populated region where few catalog stars could have ejected it. Some astronomers suggest that it may have been launched from a hidden or dim system, such as a faint binary or an isolated brown dwarf. Others, speaking anonymously, speculate that the direction is suspiciously clean, as if it had been deliberately guided to avoid gravitational interactions. Another curious feature is the object's slight deviation from its predicted outbound trajectory. As it leaves the inner solar system, Atlas shows small but measurable shifts, consistent across multiple observation points. Official reports attribute this to solar radiation pressure or residual outgassing. Yet spectral analysis shows minimal volatile activity, leaving a gap between observation and explanation. A few orbital specialists have privately suggested that the shift could reflect an unseen force acting on the object, gravitational, electromagnetic, or otherwise, though no evidence has been released publicly. Observation logs provide further puzzles. In several instances, radar and optical tracking data were temporarily restricted or removed from public servers. Administrators claimed the files contained calibration errors, yet insiders hint that the missing data coincided precisely with anomalies in Atlas's position or velocity. One anonymous researcher noted that access to raw tracking points was restored in a modified form, with certain irregularities smoothed out. Whether this was standard procedure or an intentional action to obscure unexpected behavior remains unverified. Infrared surveys add another layer of intrigue. Atlas's backtrack path passes near faint sources detected only in long exposure scans, many of which remain poorly characterized. Some analysts suggest these may represent an old, dim star system or even dispersed planetary remnants capable of ejecting objects like Atlas. Others caution that these sources may be artifacts or background noise, yet the alignment is statistically interesting and has fueled quiet speculation. Finally, a subtle pattern in the orbital data raises questions about potential underlying structure. The deviations appear in multiple small clusters along the path, suggesting repeated interactions or minor adjustments rather than a single random event. Whether these interactions occurred naturally through gravitational encounters or reflect unknown processes, possibly artificial, is unconfirmed. Some theorists quietly speculate that the orbit itself may encode information about its origin, though the idea remains speculative and unproven. Taken together, these patterns, unusual approach angle, outbound deviations, restricted observation logs, and faint potential source alignment, create a trail of evidence that is tantalizing yet incomplete. Atlas's orbit continues to defy full explanation, leaving a story written in subtle deviations and gaps. Whether these hints point to natural chaos, hidden stellar systems, or something far more enigmatic is unknown. For now, the trajectory remains a puzzle, open to interpretation, inviting curiosity and speculation from all who study it. As 3I Atlas departs the solar system, the final chapter of its brief encounter with our planetary neighborhood begins to unfold. The fact is that the object is now moving away at high velocity, retracing a path that seems almost indifferent to the gravitational forces of the planets it passed. While the main hyperbolic trajectory is well understood, subtle residual deviations remain, documented across multiple observatories. These deviations are minute, but their consistency has not gone unnoticed. The standard interpretation is that these are minor artifacts of solar radiation or measurement error, yet the pattern has raised questions that extend beyond conventional modeling. One anomaly involves the continued slight drift in the outbound path. Observations indicate that Atlas does not follow a perfectly symmetrical path relative to its inbound trajectory. Official reports attribute this to minor solar perturbations, but spectral measurements show negligible outgassing or other conventional forces to account for the small but measurable change in velocity. Some astronomers speculate quietly that the motion could hint at a natural mechanism we have yet to understand, or perhaps even a subtle, low-level influence from an unknown external source. Whether this influence is natural or engineered remains unresolved. The object's path also intersects regions of interstellar space sparsely mapped by surveys. Infrared and radio observations have revealed faint anomalies along the projected trajectory. Low-luminosity sources too weak to fully characterize. Standard explanations suggest they are distant brown dwarfs or cold stellar remnants. Yet the alignment between these faint sources and Atlas's reconstructed trajectory is intriguing enough that some researchers, speaking off the record, have speculated about the possibility of an uncharted or hidden stellar system. Whether this alignment is a coincidence or carries deeper meaning is unknown. Data handling adds further layers of uncertainty. During the final approach and early departure, several key radar arrays reported temporary outages or restricted access to raw orbital logs. Administrators stated that routine maintenance and data cleaning were the cause, but anonymous sources hint that these periods corresponded with the most unusual positional readings. When the logs were later released, some of the initial irregularities had been smoothed out, leaving questions about what was observed but not shared publicly. The absence of these data points has fueled quiet speculation about whether something about Atlas's orbit was deemed sensitive or anomalous. There are also subtle indications of non-uniform mass distribution. Light curve analysis and polarimetric readings suggest Atlas may not be a simple, homogeneous body. Some interpretations propose internal heterogeneity could account for the tiny orbital deviations observed. Others, more speculative, wonder whether the object's structure reflects a deliberate design or adaptation for surviving long interstellar journeys. No evidence confirms this, but the mere possibility adds intrigue to the study of its orbit. Taken together, these residual orbital quirks, faint interstellar alignments, and missing or altered data create a portrait of an object whose passage is fully observed yet not fully explained. The orbit leaves behind more questions than answers about its origin, its journey, and whether natural laws alone suffice to account for its subtle motions. Whether these clues point to distant chaotic processes, hidden stellar systems, or something more enigmatic remains open. The trail of 3I Atlas is now fading into the depths of interstellar space, leaving behind a record that invites speculation, analysis, and wonder.